Hello students, welcome to our video classes. And I am Anik Ghosh, your chemistry teacher with you. So before starting this class, I like to clarify something in front of you. Don't get distracted with the bandage over here because I had made a sort of accident, and right now I'm feeling well, so I just thought that I should continue. So don't get distracted by that. Just focus on whatever I'm saying, okay? And this chapter, this metals and non-metals, this is a very important chapter. Why am I saying that? Because definitely when you would go to class 11th or you would go to class 12th, so let's just think about like when you are perceiving with science, okay, throughout your life, this chapter is going to be very useful for you, because in this chapter we are going to learn a few things. Those are having they are going to get applied in electrochemistry and the other chapters like solutions, and there are several chapters those are there in class 11th and 12th. There we are going to use all of these concepts, so definitely this is going to be a very important chapter for you, okay? But today is our introduction video where I'm going to teach you about the occurrence of the metals and non-metals. Okay, so where do we find them? In which state do we find them? And like how do we extract them? This is the motto of this entire chapter. Okay, how to extract all these metals and non-metals, and how to use them. What are the physical and the chemical properties? We're going to learn about each and everything in this chapter. Okay, but today in this video we are going to learn only about the occurrence of the metals and the non-metals. Fine. Now, the first thing that you have to remember is there are several metals. Okay, in this huge list of metals, I'm just dragging out some of them. I'm just keeping in front of you some of the names of the metals. Like I'm just showing you the reactivity series. Okay, now what is this reactivity series? This is a series that tells you, okay, this is a series that tells you about the reactivity of the metal, the order of the reactivity of the metals. Okay, so as we move down the series, what happens is the reactivity of the metal decreases. Okay, so this is the this reactivity series. You are also going to use this as a metal activity series, or you are going to use it as electrochemical series as well in the further chapters or in the further classes. Okay, so let me tell you the activity series over here. Okay, so at first you can see I'm writing three of the most reactive metals: potassium, sodium, and calcium. Okay, they are the most reactive elements in the nature. Okay, apart from that, magnesium, aluminium, zinc, iron, nickel, tin over here. I'm just continuing after this. Okay, after nickel, tin should be below nickel. Okay, I'm just continuing in the right side. Okay, there should be lead as well, not important. Okay, after that, copper, Ag, Au, Pt, platinum. These are the elements that can be found in here. Okay, so this is the, like, when we are moving down the group, down the table, what happens is the metal activity decreases. The metal activity decreases down the line. Okay, so this is about the metal activity series. So definitely we can say potassium over here, this is the most reactive in this series, right? And if I ask you what is the least reactive, that is a no-brainer, it's going to be the platinum. Okay, have you noticed one thing in this series? Have you noticed one thing? You already knew about them. You already knew that these elements are going to be the the most reactive ones, and the other ones are going to be the least reactive ones. Because let's think about it. Which of the metals are used to make these ornaments? Gold, silver, platinum. They are used for making different types of ornaments or making different types of, bowls or something like that. Why do we use them? Because they are less reactive. They would not react, right? They would not corrode. They would not, get into any of the reactions with the ideal oxygen or some kinds of other materials that they may come across, they would not react. That's why we use those elements only, those metals only, for our everyday life ornaments, right? And different types of the things that we use generally in our kitchen, right? Yeah, all of them, like copper utensils, silver, platinum, these type of things are the things that we use. Platinum, we don't use it in like kitchen, right? But we use it as ornaments, gold and platinum, right? Yeah, that's why we do not use the sodium, potassium, magnesium. These things are not that much, used in the kitchen utensils or any type of those type of things, because they're not that much they're not that much, like they're very much reactive, right? They're very much reactive. Okay, for that reason, what would happen is they would react with the others, right? With the other elements that they may come across. You're getting my point? I think you know that potassium and sodium are not even usable as a metal, because both of them are very soft, right? We can, you can cut sodium with the help of a knife, okay? And it is very soft and very reactive. I think you've heard that sodium is kept under kerosene. It is kept under kerosene, right? Why do we do this? Because it is so reactive that it reacts with the aerial water. Think about it. I'm just putting some sodium in the table, okay? It would react with the aerial water, okay? The water vapor, those are there. The humidity, right, in the air. The water droplets, they are there in the air. They would react with that, okay? The sodium. After that, it would give you sodium hydroxide out of it, along with that hydrogen. And this reaction is so exothermic. I think you know what is exothermic. Exothermic is the reaction that gives up temperature, right? This reaction is so exothermic that this entire hydrogen, the hydrogen is inflammable, we know it, right? It is inflammable. So the reaction is so exothermic that what happens is that hydrogen, okay, give me a moment. Yeah, it is so exothermic that the hydrogen just gets ignited. So what happens is, when you put sodium, and what would happen is, if we just put it on the air, or on the normal atmosphere, what would happen? It would burn, right? And if you just throw it in the water, what would happen is it would burst. So this is the thing. That's why we cannot use sodium, potassium. So they are very much reactive, right? Calcium is also reactive, right? Which, when you are dissolving calcium in water, this is also very exothermic reaction. It gives up heat, okay? If someone asks you about the example of exothermic reaction, you can simply go for this type of reaction, where the sodium and the calcium, both of them are reacting with water, right? Have understood so far? Now, my point is, where do we find these metals? Do all the metals found in the elemental state, like the pure state in the nature? No, I guess, right? Look, we can try to find out in which state would we able to find them out, okay? The first thing is gold, silver, gold, and platinum, okay? So just go to the next slide. If we just think about silver, gold, and platinum, they are very less reactive, right? From the table only, we have just came to this conclusion. They're very much less reactive. And as they're less reactive, what happens is, they cannot react with the others, okay? So they remain in free state. Look, all the metals, they can be there in two ways. They can be there in the nature in two ways. One is the free state, and another one is the combined state. Either on the free state or in the combined state, okay? Now, which metals are going to be on the free state? The metals, those are less reactive, right? The metals, those are in the less reactive. But the metals, those are more reactive. They want to be in combined state. Get it? Getting it? So the combined state is only for the higher priority metals. Okay, those are there in the higher places in the period, in the period, like the metal activity series, right? Not the periodic table, the metal activity series. Got it so far? I think it's fairly clear enough. Now let's try to understand what are the ways through which you can find the metals in the combined and the free state. So I think so far we have learned that gold, silver, and platinum, these are going to be in the free state, right? Okay, these are going to be in the free state, right? Now what are the elements those are going to be in the combined state? Definitely, if I start sodium and zinc and iron and aluminium, so all of them remains in combined state. Okay, all of them remains in combined state, mean they form some sort of like some sort of compounds. Okay, now let's see what types of combined phases are there for the metals. So they can be combined with some oxygen and they can form some oxides out of it, or they can combine with some sort of sulfurs to make it sulfides, or they can also go for carbonates. Okay, they can also go for the reaction with sulfates or chloride. Okay, so these are the mainly, these are the these are the compounds with which we can find these metals, in which we can find these metals. So like either they are in oxide state, or they are in the chloride state, or they are reacting with some sulfates and all. Okay, I'm going to explain this in details, right? Now think about it. So I think you know all the anions over here. Oxides is the oxygen, sulfides reaction with sulfurs, carbonate is CO3 2 minus, sulfates is SO4 2 minus, chloride is Cl minus. Okay, this one is S minus, this one is O2 minus. Okay, so these are the combined state of the metals. Now let's see which metal combines with which of the following anions and to give what type of combined states. Let's see. Now, so as I told you, they can be in sulfide, they can be in oxide, right? So when the metals are in oxide state, when the metals are in oxide state, then what can happen? Look, let's see some, let's go through some of the oxides. So Fe2O3, this one is called hematite. Okay, and there is another Al2O3.2H2O. This is called bauxite. Okay, so these all of them you can see over here. Cu2 is also there. We call it cuprite. There's also ZNO in here. We call it zincite. Zincite. Okay, sorry, zincite. So there are so many oxide metals like this in the oxide state, right? There are other states as well, like they are in sulfides. Okay, like PBS. Okay, like HGS. Okay, like cinnabar and galena. This is called galena. This is called cinnabar. Okay, they are called galena and cinnabar. So all of them are also, you know, you can see there are the sulfide ores. There are another types of ore like carbonate ore. We call it, we use, look, for the oxide ores, this is, you can remember like this. For the oxides ore, we use ite at the end. Okay, and for the carbonate ores, For the carbonators, we use iron. Fine. We use iron. So let's understand some of the carbonators. Like we can say ZnCO3. Okay, this is called the calamine. Okay, this is a very good carbonator from which we can take out the metals. Oh, by the way, I think I have forgot to tell you about ore and minerals, right? I think you have a preliminary idea about the minerals. Like there are rocks from which we can extract the metals, right? There are rocks from which we can extract the metal, right? Now these rocks, the rocks from which we can extract the metals, these rocks can be ore. Okay, they can be ore or they can be minerals. But what is the difference? Look, the mineral from which it is easy to take out that metal is called the ore. So ore is the type of rock which is mineral only, but that helps to take up that ore like with ease. Okay, so that's why we are saying this ore word over and over again, not about the minerals. We want the ores, right? We want our expenses to be less, right? Now, so these are the ores from where we can take out the respective metals. Like from here we can take zinc, from here we can take copper. So this goes on like this. Fine, it goes on like this. Now, so this rocks. Okay, one more thing I just forgot to tell you about the chloride ores. So NaCl is one of them. Okay, NaCl is a rock salt which is the chloride source of sodium. From here we take out sodium via electrolysis. So far I think you have got a pretty good idea about all these minerals and all these ores, right? So in here what I have been trying to tell you is like the gold, the platinum, the silver, all of these less reactive metals, they remain in the free state, and all of the more reactive metals or the moderately reactive metals, they remain in the combined state. Okay, so in the combined state we have oxides, sulfides, sulfates, and different types of other like carbonates and all. Okay, and the thing is we have learned about the minerals and the ores as well, right? So ores are the minerals which is special, which from which you can take out the material very easily. So if you are searching for iron, you need to go for an iron ore. Okay, not an iron mineral. It would be easier. So you should go for hematite. That's why I am writing hematite in there, because we should be focusing on the ores, not on the minerals. Okay, from minerals it is very much difficult to take out the particular metal. After that, what are the processes through which we can go to take out that metal? From there only we are going to learn in the next class. So I think you have understood all of it. This is a very simple topic and a very short video as well, but this is just the introduction to this class, and we are definitely going to meet in the next class. Okay, and definitely you just go through it, otherwise it would be very difficult for you to understand it, okay, later on. So right now what you have to do is just go through go in the way I am going. Don't skip any of the videos. Okay, it would cost you a little bit more than what you think. Okay, so that's it for today. Thank you for your attention, and I think we are going to meet in the next class. Please have a go with the entire PPT before going to the next class. It will be very helpful to you. Okay, so bye then.